like to introduce David Talby from John Snow Labs. He's going to talk to us about lessons learned applying large language models in the healthcare space, which I think is highly relevant for other spaces as well. And his term for this conference is he's a builder. Thank you.
Thank you. Thanks. Hello, everyone. Thanks. Can we please get the slides on the screen? Thank you. So my name is David. I'm from John Snow Labs, and my goal today is to talk to you about 3 things we've learned, actually applying those new technologies specifically in the healthcare and life science space. There are some things that we learned that seem a bit surprising based on what everybody else is talking about, so I'd be curious to hear your feedback as well. So the first thing that we see in almost every application is that when we look at Gen AI solutions in healthcare and we look at how we actually use the LLM, mostly we only use it as really as a user interface. So as the way you ask the question, get your answer, but really nothing else. And here's what I mean. So here's one example. This is a project with one of the top 5 payers, so basically health insurance plans in the USA, and they operate in all 50 states and a few other areas. And in each one, they have more than 100 plans. So when you call their customer support and kind of say, oh, I need to get braces, I need to do a hip replacements, what are my copay, what's the facility pay, do I need to get pre-authorization, what's going on? Often it takes their own support team like half an hour to an hour to find the answer from you. Because each plan is a legal document that's about 100 pages long with all fine print, and all the fine print is relevant, and all the fine print could mean a lot of money to you. And the ask was, well, can you have your magical algorithm read those documents and just provide an answer, so I can just type in a question and just give me the answer. But the important thing is you have to answer for each patient from only that specific document, right? Because they're on the Arizona Bronze XGB8 plan of 2019, right? And not anything else. So you need to read the document, you need to give me a straight answer. And once I give an answer, it's legally binding. So no hallucinations, no mix-ups, nothing like that. So that's one example. Another example was also one of the top 5 pharma companies in the world. And what they want to do is they want to build a chatbot for patients and other people who take care of patients, like their kids, their parents, to ask about drugs, right? So I was just diagnosed with this super scary thing, like epilepsy, something that would cause hearing loss, vision loss, another issue. And I want to understand, like, what is this if I take your medication? What are the side effects? What's going to happen to me? What's the prognosis? What do I need to be? Do I need to make any lifestyle changes? And you want to be able to have the discussion. It needs to be in a friendly tone, ideally in multiple languages. But the most important thing is, when you answer questions, thou shall only use the specific documents that these specific pharma companies submitted to the regulators within this country. So you do not answer based on Reddit, you do not even answer based on PubMed, you do not answer based on what the FDA and CDC say. You answer based on only these documents that we made public. Otherwise, also the pharma company may be legally liable because, we told the regulators that these are the side effects, but now we're telling patients something else. Another example is from the provider side. So healthcare providers are the actual doctors, nurses, the people who actually take care of you when you're sick. And within there, the multiple projects where people really just want to ask about their patients. Okay, so just look at my patient database and give me all the people who've had a heart attack in the last year, but they're not on beta blockers yet. Okay, I want to compare people who've done a knee replacement. I want to compare how many of them had to come back for to redo the surgery, and please compare people who've had opioid use and no opioid use before, because I know there's some gaps there. So what I'm looking for, obviously, this is very private information, but also what I want is I want to have that user interface where I just ask questions in natural language and you just give me the answers. Okay, but it has to be based on a very, very specific data set that I give you. Okay, and that's the only one I want you to use. So those are some of the use cases we're seeing, across the provider space, payer space, pharma space, and those are things that people have wanted to do for years and are now actually doing it. And here's what we see across all of these use cases. So first of all, people really like the kind of the ChatGPT, the chatbot experience. Okay, and it comes out they don't really like reports and they don't really like dashboards and they've never liked, really search and all of those things that really require a lot of work and a lot of understanding in the user interface and the data schema in terms of how you do those things. Really all they want is just to ask a question. And the reason we know this is because this is how they already work today. What they do is they have these huge complex data stores and they have whole teams of people who are BI analysts or data analysts. And they just email people, right? They just email people on that team a natural language question by email, and then they get the answer, right? And this comes of, well, can we just, have your super smart AI system just give me that answer? So people really want that really as the user interface or the way they interact with the data. But that's all they want. What they do not want the chatbot to actually answer anything from its knowledge or its memory. Okay, and they're very, very specific about it in every use case. Okay, so you'll only answer for the documents I gave you. So I ask you, what's the capital of France? The answer is not Paris. The answer is, go to the knowledge base, to the database, find the answers there, show me what document this answer is in, and show me that answer in the document. If you do not find the document, the only correct answer is I don't know. Okay, and this is very, very important because I need to control which documents and which versions you're taking the information from. Right? Because in medicine, it's not just about what the answer is, it's kind of where did you find it. So I want to be able to choose which knowledge bases you use. I want to be able to update them on a very regular and real-time basis. And I want to make sure, basically, there is zero creativity. The other very important thing in healthcare is explainability. And explainability here, from every use case we've seen, is not a responsible AI feature. It's the core way people interact with the system. Because in healthcare, there's very rarely one answer. So what's the capital of France? Oh, it's Paris. In healthcare, there are many, many different definitions for the same thing. So if I ask, for example, give me all the diabetic patients, and I see a list, and we see doctors do this, you kind of say, well, she's not diabetic. Like, where did you get this? And what you learn is there are many definitions of what's diabetic. One definition is someone who has the diagnosis code in the EMR saying they're diabetic. Another answer is, oh, they've had 2 abnormal H1C tests in the last 6 months. Another answer could be, well, they told me they're diabetic. Okay, another answer could be, well, we see they've been on metformin for the past 3 years and they've got to be diabetic, right? They're on the medication. And all of those are good, but they're good for different use cases. Okay, similarly, when you're looking at drug discovery and pharma companies, looking at biomedical research, and you ask, oh, what are the known side effects of this drug? You give them a list and next answer, like, where did you get this list from? If it's what's written on the drug, kind of on the product sheet, well, that's bullshit. It's just everything that came up in a clinical trial. If it comes from papers, like which paper? Is this a meta review? Is this recent? Was this a clinical trial or prospective study or retrospective study? How many papers suggest the same thing? Because honestly, you can find a paper that says that vitamin C cures cancer, right? You can find a paper for anything. I want to know what's the medical consensus. Okay, I want to know if this was a study on humans or mice, right, or something in between. So very often what people want, they ask a question, but then they want you to ask again about the definitions, about the document, and then you want to ask about specific document. Okay, let's go into this paper. How many patients did they have in this study? Okay, what was the metric they used? I want to understand if I can trust it. So these are the main implications from a technical perspective, and really what we're seeing is fairly, very consistent in healthcare. First of all applications need retrieval augmented generation. Okay, and it's even stronger than that. You need to have very strong safeguards to come say, don't use the LLM to answer. Okay, I don't care you trained on the entire internet, it knows nothing. You only answer from the specific document. The only thing the LLM does, once you give a query, choose where to ask the question, and then reformat the answer, show it in nice bullet points, and it really is just a user interface play. The other thing, we see that being able to ask about a specific document is very important. Oh, here is this patient. What is their tumor staging right now? It's, here's the TNM value. Where is it? Oh, it's here. 9 weeks ago, we have this discharge note, we have this pathology report. Here's what it says, you can read it. Pathology reports. How many other pathology reports do they have? Show me all of them. Okay, who did it? Right, which lab, right? Do they have an abnormal lab result? When was it? Before or after we put them on that medication? Okay, so going down to specific documents as context is very, very important. And the other very interesting thing is there's a lot of talk about LLM tuning. I'm yet to see an example we actually need to tune an LLM, because said the NLM does not actually answer anything. So if you tune the NLM on all your patient data, or all medical research, or even all your specific clinical guidelines, it really doesn't help because you don't use it to answer anything, right? You really need to be able to update the backend databases. So this is one interesting thing that we are seeing in this space. The second interesting thing that we are seeing, and I would say I've definitely qualified this for healthcare, but we're seeing it fairly consistently in the applications, kind of in the use cases we see, is that the current model, I mean, they really suck at information extraction. And here's the background. So Johnson Labs, we're a software company. We've been around since 2015, and our focus has always been on healthcare and life science. And what we do is we provide the industry with state-of-the-art natural language processing. So we serve the majority of the industry, so the large academic medical center, pharma companies, tons of software companies in this space build on us. And our one call to fame is accuracy. Okay, so we wake up in the morning, we read all the new papers, we look at all the new open source model. Every time someone claims that they have something slightly more accurate, we try it, we reproduce it. Often it doesn't reproduce. If it reproduces, often it doesn't generalize. But if it does, our job is to give you the production-grade, trainable, scalable version of that. Okay, and really provide kind of the best accuracy possible across everything that's out there. So that's what we do, and we also we make some publications. So last year we published around really new state-of-the-art accuracy around biomedical entity recognition, adverse event detection, de-identification, relation extraction. And a lot of it is really kind of the engineering work of taking a lot of techniques and ideas and really apply them to this specific space, to the medical space, and seeing what works. And the biggest question we get this year is, like this year we're all moving to LLM, like have you moved everything to LLMs yet? And our answer is, well, no, because they're not really good at this stuff, right? Which is often surprising to people. But here are a few examples. So one use case is being able to extract what's called social determinants of health from a patient record. Social determinants of health are all the things in your personal life, social life that impact how healthy you will be, how long you will live. Okay, so do you have health insurance? What is your level of education? How is your diet? Are you homeless? Do you have enough food? How is your sex life? Right, so all of the things that will keep you healthy, but are not actual diagnoses. And you want to be able to read a note and extract those things automatically. And you can do it with prompting, or you can do it with there are many other techniques, transformers-based, few-shot learning-based, and others. And one of the things we've seen, we've compared the current state-of-the-art models we have with GPT-4, and this is fairly recent, with a whole lot of work on prompt engineering, and we see the GPT-4 makes 3 times as many errors. So that was one example. Another example was basically with more general entity recognition. So in these examples, you can see pathology reports, right? So specifically in oncology. So we're looking to understand cancer diagnosis, treatments, tumor staging, tumor histology, different dosages of chemotherapy, biomarkers, right? So ER positive, ER negative, and so on. And also, we've compared this to ChatGPT, different versions, and all of this. I mean, you have the links here. We made the notebooks public. We make the code public. We worked with quite a few more than 300 academic medical centers. We give the software for free so people can reproduce and kind of help us improve this. And we see really just kind of the best you can get with the current GPT model gives you twice as many errors as what the current models that we have do. We're seeing the same thing when you're looking at normalizing entities to codes. Okay, so I have a text, and the text says, you have this kind of bone fracture in your left leg just above the knee. There's a code for that over several, there are tens of thousands of ICD-10-CM codes, but there are drug codes, there are lab test codes, there are medical device codes, there are adverse event codes. And we see the GPT models, they're extremely bad at basically mapping to the right code based on a medical context. And we've seen the same thing around probably one of the most popular tasks today, which is de-identification. We're seeing also, we looked at kind of GPT-4, and you can see on kind of the classic public benchmarks for the identification, it makes more than 5 times the errors. And it's still pretty good. So with GPT-4, you can get to 93, 94% accuracy. But the thing with de-identification, right, if you want to say, oh, this data is completely de-identified, you can basically can make it public, right? You can use it for other things. You can use it to train other models and not have data leakage. Is either it's completely done. So either you're over 99% accurate and you can certify it, okay, legally and come say this is de-identified, or you come and say, well, I'm almost good or I'm pretty good, which still means that a human has to look at each and every one of them, right? So from a customer perspective, that's not very useful, right? Because I still need to pay people to read the whole thing one by one. It's going to take much longer. And de-identification is one of those areas where about 3 years ago, we did reach a point where automated de-identification of just free text is as good as manual. So we can consistently get to 98, 99% accuracy, which is better than what humans do. And this still seems like a step back. On top of that, there's the cost aspect. And we have here, we have one of the large public case studies we have is with the Providence Health, which is one of the large healthcare systems in the US. They treat more than 25 million people per year. And they use the software to de-identify, here on the case study, it's 700 million patient notes. They more than doubled that number since. And they've done a lot of optimization to save on just compute cost. And they reach around 1,500 notes per dollar, right? So that was the metric. How many pages of medical data can I identify basically for $1 of compute costs? And they recently compared it with what you can do with GPT-4, and it was 2 orders of magnitude. It was 15 notes per dollar versus 1,500 notes per dollar. Okay, because what you need to do, you need to set the note, you need to set the prompt, you need to get it back, right? And even if you assume you get a similar level of accuracy, the difference in cost and difference in latency here is immense at scale. So, at this point, we're seeing this very consistently, and we're wondering, like, are we the only crazy ones? What's going on? And one thing that's happening, and you see this more and more in the healthcare space, is apparently we're not. Here's one example, but there are quite a few academic papers now that are basically saying the same thing. Look, just use like a nice, small, pre-trained, tuned deep learning model versus what you can get with GPT-4. It's like just not as good. It's really just not as accurate. Here, they've done comparisons on entity recognition, relation extraction, and multi-level text classification. And they compared with PubMed BERT, and honestly, PubMed BERT is nowhere near the state of the art, right? It's 3 years old. It's not something we would ever recommend using for production systems. It's like PubMed, Clinical BERT, BioBERT, kind of those set of models that were like the early healthcare-specific transformer models, and still they found huge gaps in accuracy, kind of between really 10 and 40 points in F1 score from what you can get on these tasks. Which leaves an interesting question, which is, okay, why is everybody so excited and happy and moving in that direction? And there's a very obvious answer here, which is this. What's super easy to do with the new GPT model, and it's super intuitive to people, is doing few-shot and zero-shot learning. Okay, and this really is the game changer in terms of how you build these models. So here's one example where you can do prompting. So let's say I want to read all of the medical research, biomedical research ever published, and I want to build a knowledge graph, a database of drugs and side effects, what's called adverse events. So an adverse event is a bad thing that could happen to you when you take a drug or use a medical device. So I want to build that, to build it. The challenge is that, this is something you cannot do with rules or regular expressions or kind of basic machine learning models, because there are going to be many, many sentences that talk about symptoms and drugs, right? But could be this drug treats this symptom. Could be, oh, these drugs often happens with this symptom. But we want, we want something that says, no, we have evidence that this drug actually causes this side effect with people, right? And that's an unknown side effect. That's not the main thing we're treating for. But what you can do with the current GPT model is really literally just give it 4 examples, right? Just kind of say, okay, here's the prompt, okay? And, real prompt, if you do prompt engineering, it can be a bit longer and more refined than that. But you can say, look, I'm going to give you a sentence or a paragraph, and I want to classify whether this does describe an adverse event of a specific drug, yes or no. Here are 4 examples, not 4,000, not 400, not 40. And the That's it. As you can do, I don't collect training data. I don't label it. I don't test it for responsible AI. I don't have data scientists do stuff in Python. I don't do hyperparameter tuning. I don't build an API for it. I don't do anything. I just do the prompting. I mess around with it for a while. I give it a few examples, and that's it. It's done. It's ready. There's an API you can call it. Just use the prompt. It's, just scale it. So just the prompt, and then based on these examples, okay, classify these. That's it, right? And you can give it 2 examples. You can give it 2,000 examples. And it works, and it works reasonably well, right? And that is a game changer because really what you can do today, which you could not do 3 years ago, is you can get decent accuracy, not great, but good accuracy, with someone who is not a data scientist, not a programmer, not a software, not anything, right? Someone who has a bit of domain expertise, right? They can do it literally for 1 hour, right? And they can get you to what used to be the state of the art in maybe 2016, 2017, right? So you can get to pretty good accuracy really with almost nothing, right? So it's almost like, you can build a whole web application, have a whole Java stack on Kubernetes and do the auto-scaling, or you can just do something in Excel and be done with it, right? And if it gives you the result, it gives you a result. And that's very exciting. And right now there's a lot of work and a lot of paper who people who say, okay, let me just do that. And you can also use zero-shot for entity recognition, for relation extraction. That happened as well. You just give it prompts and say, find the cases where people have these diagnoses, people have these risk factors, those specific things. And that is really fantastic. If you do that, which you should in some cases, there are 3 things that you should pay attention to. First of all, zero-shot learning, few-shot learning does not mean you have to use an LLM. Actually, the best and most accurate zero-shot and few-shot models do not use very large language models. You can have fairly, not small models, but 1 to 3 gigabyte models, at least that we're seeing if you train them to a domain. The examples I showed you last few slides are actually from our library, and you can see kind of the level of accuracy you get, and here's how you tune them, that's it. That's the entire training and tuning process, right? So if you want to recognize entities, you can say, the age entity, it's whatever answers the question, how old is the patient is, or when was their birthday, right? And that's it. If you find something that answers the question, just mark it as the age. That's it. And that's really all it needs to know. Same thing with relationships. Well, I want to find 3 kinds of relationship with, something causes something treats something, or something has nothing to do with something. And, that's it. And I don't need to show you, grammar or synonyms or anything of the sort. This gives you easily an order of magnitude better latency and better cost. Many of these models are open source, so that's probably where I would start if I were you. The other super important thing is stick with healthcare. So the thing with zero-shot is it only works because you use a pre-trained model that's already specific to the domain, right? So the reason it knows that, if you have a sentence like, aspirin alleviates headaches, and you don't need to, of course, it doesn't have to be an example in the training set because it already knows that aspirin is a drug, it knows that headache is a symptom, it knows that alleviates is the kind of verb that you use in healthcare papers. So it already knows all of that. So you need something that already knows kind of a lot about healthcare. So that really, when you tell it, you kind of say, okay, look, I assume you're a super smart doctor. Here's what I want you to do here. Here's the specific task, but I need to tell you very little to train you for that specific task. So definitely start with something that's domain specific to your domain, whether you're doing healthcare, legal, anything else. And the other thing to do when you make the choice, really it's an accuracy, a lot of it is accuracy versus speed and scale. So right now, for example, our library can extract more than 500 medical entities out of the box. And that gives you state-of-the-art accuracy, right? So kind of far better accuracy than we get with these models. So the first thing you should do, just look for a pre-trained model. Okay, from my experience, there probably is a pre-trained model. It will give you better accuracy, better speed. You can run it at scale, run it privately, start with that. If there is no pre-trained model, your second course of action is definitely, start with zero-shot and few-shot. It's a much faster way compared to going and training kind of and optimizing a model the whole way from scratch. It works really well, scales very cost effectively, but you're going to get accuracies in 70s to 80s in terms of F1 score, so it's really good if you're going to have human in the loop. Okay, so for example, if you're building a patient registry for rare diseases, okay, and you kind of say, okay, I want the model to auto-populate, but then I have someone go one by one and check it before I actually contact patients or submit this to regulator or make a treatment plan. So as long as you have a human in the loop and you can say, look, I don't really need 95% accuracy, actually 75 is fine. It saves me time, it's useful, just go with that. Your third option is to go with one of the LLM APIs, so OpenAI, Courier, Anthropic, one of those. This works really well because, it's super easy. You just open your browser and you just do it, right? So it's no code, no install anything, it just runs. Once you've done it, people know how to use it immediately. The only issue there really is around cost, right? So if you need to do this for 1,000 patients or 500 patients, just do that. It's going to be very cheap. It's probably going to cost like $2,000 and you'll be done with it. If you need to do it for 100,000 patients, then definitely not. Right? Definitely you want to go with one of the zero-shot or a few-shot learning algorithms that are there. Otherwise, the cost difference can easily be 5x, 10x, 20x. So those are kind of the three choices, and really you just need to know which one you pick. So here are the three things we talked about. The one request I have from you, some of them kind of go against a lot of what people talk about in terms of, should I only do LLMs or should I use pre-trained models? How do you really use the LLM, or do I need to do LLM tuning for domain? And we see a lot of the companies in space, a lot of our customers, other companies kind of struggling with the first POCs because they go by the playbook and the playbook doesn't work as well for healthcare. But I would say it's very early days, so my one request would be, if there's something you disagree with, some of you think other things work, really I would appreciate the feedback, because I think we're all just in our first year, we're all learning together. So I definitely appreciate the opportunity to learn from you as well, and hopefully next year we join again and we learn more, we know more by then. And with that, thank you very much. Here are my contact details. And would be very happy to talk and, and see how we improve healthcare together.